So today I'm going to talk about the VGA. This is in chapter 9, which is an online supplement in the textbook. So you can go to the textbook website, DDCAbook.com, click on the Risk 5 edition, and you can download chapter 9 and read about VGA, or video graphics arrays, as well. So what is a VGA? VGAs display red, green, and blue on a display, on a screen. And it displays those values. You can specify what value you want to display at each pixel. So each of the colors can have up to 256 possible values. So from 0 to 255. So they are stored in an 8-bit value. So for example, if we wanted to display the value, the color red at a pixel, we would max out the value of the red value and zero out green and blue. And similarly, if you wanted to display blue would be its max value, 255, or in hexadecimal FF. And if you wanted to display purple, would put red and blue on at that pixel. So a VGA screen has some resolution, so some number of pixels. So for example, here is a 640 by 480 pixel display. So it has 640 active pixels in the X direction and 480 active pixels in the Y direction. And each of those pixels can have the value, or will have the value that we give to it. So for example, if we wanted to make a pixel red, would make its max value, and green and blue 0. Okay, and so each of these is a pixel, so there's 640 of these across, and then 480 of these pixels down. So originally, VGA operated with an electron gun, one for each color, that scanned across the scan lines, and each of these is a scan line. And then it would go to the next one. So it would go, scan across that line, and then return and go to the next line and start scanning across that one, and then return to the beginning and scan across the next one until the entire display has been displayed. So in addition to the active pixels, we also have what we call a back porch, a front porch, and synchronization, quote, pixels, but really it's the amount of time it takes to bring that, or originally to bring that electron gun to the beginning. And so the back porch, for example, can have 48 pixels, and the one shown here. Front porch has 16 pixels, and then it takes, for syncing the horizontal originally electron gun back to the beginning, it took 96 pixels. And so the entire scan line is actually 800, right? The addition of these 48 plus 640 plus 16 plus 96 is 800 pixels. And then same thing for vertical. We also have a vertical back porch, a vertical front porch, and vertical sync, so that when we get to the bottom corner, it has time to go back to the top corner to start displaying. And so the back porch and front porch are not displayed on the screen. The ones in blue here are what we see, but we have to also account for those in our timing and in our code. Okay, so again, the actual display shows 640 by 480 pixels, but we have to manage 800 by 525 pixels to account for the back porch, front porch, and these synchronization times. Notice that the vertical numbers are in scan lines. So we have 32 scan lines. Remember, a scan line is this entire thing. Right, so we have 32 scan lines in the vertical back porch, 11 in the vertical front porch, and 2 for synchronizing back to the beginning of the screen. So again, here written, black and front porch have no image on them. Horizontal sync time is the time to move the gun back to the beginning originally. And now it's just, we have to work with this original protocol. And the vertical sync is the time to move from the bottom corner back up to the top. So let's suppose we want to refresh the screen 60 times per second. So in other words, the refresh rate is 60 Hertz. Our eyes don't detect a change at this rate, and so that's a good rate to have. 2 Hertz would see flickering, but 60 Hertz is a good rate. So if we have 800 by 525 pixels, in other words, a total of 420,000 pixels per screen, and we want 60 of those per second, so 60 screens per second times 420,000, times 420,000 is around 25 million, so 25.2 million. And so we can make our pixel clock, in other words, the clock that says, okay, new pixel, new pixel, new pixel, about that rate. So if we make it 25 megahertz, in other words, with a cycle time 1 over that of 40 nanoseconds, that will give us a refresh rate of about 60 screens per second. So you can mostly ignore this slide, but it shows the timing of displaying a screen. And for this one, it just displays a single line. So horizontal sync is going to be high during the front porch active and back porch active time and front porch time. So it'll be high. And then the horizontal sync goes low during that 96 pixel clock. So we'll have 96 pixel clocks where it's low to say, hey, we're syncing back originally that electron gun back to the beginning of the next line. And then you can see the timing. So we'll have a back porch where there's no RGB values sent. They're just 0. And then during the active pixel time, we'll send RGB values for 640 pixels. And then the front porch time, in this case, is 16. Also, no pixels are sent. And then it just repeats. So each of those is a scan line. So from here to here is our 800 pixels. And then it repeats for the next 800, the next scan line, 800 pixels, and so forth. So here's the VGA module, and you can see that it has some inputs, clock and reset. That's the system clock. And we'll use a switch 0 to reset it. And then we're going to produce this VGA clock. That's that 25 megahertz clock. And these synchronization signals, and then most important, will output the RGB values to the display. And so this is really what you're going to be manipulating, is those RGB values. So the control signals for the system are the clock. That's our 50 megahertz system clock. Like I said, the 25 megahertz pixel clock that we're going to generate, and then the synchronization signals. The data signals are the ones that we're going to manipulate. So those are the important ones that we're going to drive as the output. And so these are the main modules, VGA controller, and you won't need to do anything to this module. You won't change it. It keeps track of the XY values using counters, and then outputs control signals, like we talked about, and then it's going to get the RGB values. So note that in that module, VGA controller, the X and Y values are called H count and V count for horizontal count and vertical count. Video gen stands for video generator, and it receives the current X and Y values, H count and V count, and then outputs the colors R, G, and B, possibly dependent on the current pixel location. So in other words, the current X and Y values. So that is the module you will change. So VideoGen is the module you will change, and possibly its submodules that support it. So here's a VGA controller. Again, I'm just showing it to you for your interest, but you know, really you're not gonna change it. You can see that it shows these you know, different values: the horizontal back port, the active pixels, the horizontal front port, the horizontal sync, and the total. You know, add them all together is the max value or the total value of that line, and same thing for the vertical signals, vertical back port, active or vertical parameters. And then, you know, has these inputs and outputs, but the main thing we're gonna use, and again, you're not modifying this module though, is the X and Y values, also in this module called horizontal count and vertical count. And so here's the VideoGen module, and this is the one you will modify. So video generator is going to generate or output the RGB values dependent on the X and Y values. And so here's a very, very simple VideoGen module. This is not the one posted in the lab, but I will post these on the course website, on the lecture website. And so this is a very, very simple one, just to show, you know, all it's doing is taking X and Y values and outputting the red, green, and blue values that it should be. So this is displaying blue on the right side of the screen. So, you know, for example, if that were our screen, it's going to say, hey, if X, so X is 0 and Y is 0 starts here. So that's the 0, 0 point right here. And it's going to increase, X increases to the right, and Y increases down. So this is X and Y is increasing downwards. Okay, so this is saying if X is greater than 120, so, you know, somewhere here, make this blue. So red will be 0, green will be 0, but blue will be its max value. So if X is greater than some value there, it's going to make all those pixels blue. Otherwise, it's going to make those pixels black. So this will display blue on the right side of the screen. Very simple VideoGen module. Here's another relatively simple VideoGen module. It's saying, okay, so we're going to have this recgen or rectangle generate module here. And we're going to say, okay, we're going to give it the current XY position and where we want the left top and right bottom of a rectangle to be. So if we had a rectangle, this XY value is left top. That's the XY value of this corner here. And then the XY value of the bottom corner, bottom right corner, is right bottom. Okay. And so, if we specify that, we can specify where that rectangle is. And this basically says, hey, if the pixel that we are giving it, XY, or that we're at, is inside of that rectangle, we want to assert this signal says, hey, yeah, you're inside that rectangle. So in rect goes asserts. Okay, so if let's say we have an XY value that's somewhere here. It would say, hey, if X is greater than or equal to left, it is, and X is less than right, it is, and X is greater than or equal to the top, Y is greater than or equal to the top, remember Y increases this way, it is, and Y is less than the bottom, it is, then it'd say, yes, that's inside the rectangle that I want to draw. Okay. And so this recgen module is basically saying, asserting this signal that says you're either inside, in rect is 1, the rectangle you want to draw, or not, right, if in rect is 0. And so we're going to basically instantiate this recgen module with some pixels, saying what in this case, the left top is 120, 150. So X, remember those are X and Y values. And the right bottom, XY again, in XY order, is 200, 230. Right here. So we're feeding those in as well as the current pixel value, the XY value of the current pixel that was fed into this module. And then we're going to get out from RecGen, just like we just talked about, this inrect output. That's an internal signal that says, okay, that'll be 1 if you're inside that rectangle. And this says, assign RGB if you're inside of it, assert the green, max out green. So in other words, make that pixel green. Otherwise, don't light that up. Don't light that pixel up. Make it black. So this simple generate rectangle module would look something like, so let's see, 120, something on the order of this. We draw a red, a green, excuse me, rectangle. Anywhere inside there would be green. And obviously it's not drawn like that, right? It's drawn like this. That pixel, then that pixel, then that pixel, right? Until they're all done. And then it goes to the next line and draws that pixel and so forth. Okay, and in the VGA module that I gave you, this is inside of that VGA module. The last one is the most complicated one, and you can, for this lab that's coming up, you can ignore it for now. I'll give a brief overview, and we can talk about it more later as well. But for this video gen module I'm showing now, it only displays the characters. It doesn't display the rectangle on top of it. The one in the lab, I put those together. So, all right, so this has a character generation ROM. So it has a ROM here that is going to tell us, basically give us characters. It's also called a pixel map for each character. And we can feed in some value. It's basically going to repeat every certain value on Y. And so we just feed in the bottom values of Y, so it'll repeat every, basically 8 pixels, right? This is a 3-bit signal. And so the Y, as we go across, every 8 values of Y, it's going to repeat. Those bottom 3 values will repeat, right? So it's going to go 0, blah, 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 all the way up to 7 as the Y value. And then it's going to go 8. And you can see and then 9. And now those bottom 3 pixels repeat. So it's just going to, what this is going to do is going to repeat A, and then A every 8 pixels in the Y direction. A. And then the X value is going to determine what letter we write. So this X value will say, okay, this is what I'm going to read A, next time I'm going to read B, next time I'm going to read C, and so forth. Actually, that X value tells us which line in this. So A is actually going to be a bunch of pixels that we define. This first line will be X is 0, next line will be X is 1, next line will be X is 2, X is 3, and so forth. And then these upper bits of Y are going to tell us what letter to write. A, and then we'll increment by 1 after 8 pixels, B, C, blah, blah, blah. Okay, so this is going to tell us, we're going to read that character generation ROM and get out whether the pixel should be on or off. And then every other character, we're going to make the character red or blue. Okay, just depending on this Y3 value. So this is going to toggle. If it's 0, make it red. So if it's 0, make it red. If it's 1, make it blue. So it's going to go red, blue for the different characters. And then green's just going to be off. So we're only going to display red or blue. And here's the character generation ROM. The main thing is we're going to read this this text file. So it's similar to the way we read test vector files, but it's going to read into a memory. So we call it a ROM, a read-only memory. And we're going to read these different values. And so each of the characters is going to be 6 bits wide. And so we're going to. Okay, so here is the content. Here are the contents of our ROM, and each of the lines has 5 values, 5 bits. And so our characters, so for example, here's an A character, the ones highlighted in blue here show A. And as we go along to display this, we'll be displaying just one of these lines at a time. So we'll be displaying 0, 1, 1, 1, 0, 0. And we actually pad it with, so this is only 6 pixels or 6 bits. And so we're going to add 2 more bits there. And so, that line will just repeat itself, and we'll be getting A and then another A. But we're, again, remember doing it line at a time, so dot, dot, dot. And then we'll come back to the next scan line, as it comes back around, once it finishes that line. And then we'll grab the next line of the letter. And now, again, it will pad with the zeros. And then we'll get 1, 0, 0, 0, 1, 0, and blah, 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 until we get the entire character drawn on our screen. And so there are a bunch of intricacies with this. For example, when we read out the line, if we read out that top line, our Y value is incrementing from 0 to 1, but what we just read is going to be bits 7 to 0. But the X value is incrementing, I might have said Y, but the X value is incrementing from 0 to 1. So we want it at the offset of 0, 1, 2, 3, 4, 5. That's where we want to print those values. And so we'll have to actually reverse what we read and first display that value and then the next one and so forth. All right, that's it for VGA. Mostly focus on the basics of VGA, which is everything except for the character generation. This one's a little bit more tricky than the other ones. So focus on, when you're first learning about VGA, focus on the first, how VGAs work, and then the first 2 examples that I gave, just drawing, a very simple one where we just display a blue kind of area on the screen. Right, the one I showed was a vertical area, or actually on the right side of the screen. But you could also do it, display if Y is greater than some value or Y is less than some value, you show a different color. And then also the rectangle. And then after that, you can start looking at the code for character generation. All right, that's it for VGAs today.